In this question, given that y times root of x square minus 1 is equal to log of root x square plus 1 minus x. You are asked to show that x square plus 1 dy by dx plus xy plus 1 is equal to 0. So now, given this expression, let us differentiate this on both sides. So in the LHS you have a product function. So we'll use product rule. On the left hand side you have a chain composite function, we'll use chain rule. So what is the differentiation of this? Y times the differentiation of root of something is 1 by 2 root x square plus 1 times the differentiation of x square is 2x plus root of x square plus 1 times the differentiation of y is dy by dx is equal to. So what is the differentiation of RHS? This is log of something. Log of something's differentiation is 1 by something. That is 1 by root x square plus 1 minus x. 1 by something into the differentiation of this. So what is the differentiation of this? Again, this is root of something. 1 by 2 root x square plus 1 into differentiation of x square is 2x minus x's differentiation is 1. So 2 and 2 gets cancelled here, 2 and 2 gets cancelled here. So this implies xy by root of x square plus 1 plus root of x square plus 1 times dy by dx is equal to. On this side you have 1 by root of x square plus 1 minus x into. So if you take the LCM here, you get x minus root of x square plus 1 by root of x square plus 1. So as you can clearly see, these two terms are related. So if you cancel these two, you get a minus 1 which is left out. So this implies, so if you take the LCM here, xy plus x square plus 1 times dy by dx whole divided by root of x square plus 1 is equal to minus 1 by root of x square plus 1. So root of x square plus 1, root of x square plus 1 gets cancelled. So this implies, so as you see here, if you just take this one onto this side, you're asked to, you get what is being asked. So x square plus 1 times dy by dx plus xy plus 1 is equal to 0. So this is what you're asked to prove, so hence proved.